Hello guys, in the today's class we shall discuss second chapter of your module 1, that is relay construction and operating principles. Okay, at the first we have introduction part. So we know that a proper operation or proper operating power system should have the following requirements, that is efficient, it should be reliable, as well as fast acting protective schemes. There are three things which any power system should have in it so as for proper functioning. So basically power system consists of protective relays as well as switching devices, that is your circuit breakers. So your protective relay acts like a brain, so where it sends commands to the appropriate circuit breaker to trip or make the circuit. So it detects abnormal conditions on a power system, thus by constantly monitoring the abnormalities in the system, so which differs the parameters from normal as well as abnormal, that is fault conditions. We know that the basic electrical quantities which likely to change during any abnormalities or any during faults are like current, voltage, as well as phase angle and frequency. So protective relays utilize all these quantities to detect the abnormal conditions on the power system. Okay, you can see here this is the basic relay circuit which is shown here, and again this functioning has two ways, means it works in two ways to function. So one is without battery and one with battery. Okay, we are going to explain this circuit with first way operation is with battery, second operation is without battery. Let us consider the first case, that is with battery. Okay, here you can see that this is a circuit breaker which we need to energize, and this circuit breaker is energized by using this trip coil. So let us consider this battery is present in the circuit like it is shown in the figure. So here you can see that here a current transformer is connected on the same line of circuit breaker where it is connected, and this is the bus bar of three phases. Okay, and again this is the current transformer, this is the primary and this is the secondary. This is the current coil of the relay, and this the dotted line which is shown in the diagram is what is all a relay, the internal parts of the relay. So whenever the current flows in the, that is secondary side of the current coil of the relay, then what happens, this contact will get closed. In here it is open, now it gets closed. So whenever it gets closed, then what happens, as we know that battery is connected, so this already has certain voltage, so what happens, current starts to flow in this particular circuit. So here what happened, our current transformer senses any abnormality here in the bus bar or in three phase line. So the same thing is what, like I told you how the current transformer is converts the current from higher value to lower value. So depending upon that, what happens, this contact gets closed. This is the relay part. So due to that, current starts to flow in the trip coil. So whenever current starts to flow in the trip coil, so it energizes the circuit breaker, and depending upon the design and all, the circuit breaker will take the action, necessary action. The second way, you can see that I told no already that we are going to study the operation of this relay without any battery. Assume there is no any battery, instead of battery it is a closed circuit from this point to this point. So station battery is not there, it is shorted. You can assume like what, it is a shorted part. So whenever the current flows in the secondary part of your current transformer, so whenever the relay gets operate, then what happens, again we know that whenever this relay operates, this contact gets closed. Normal it is open, whenever relay operates it will be closed. Even after there is no any battery connected, so what happens, due to the induction and what happens, current starts to flow in the trip coil and trip coil gets energizes, and the same thing what the circuit breakers will do, that is even the circuit breaker will act upon the energizing of the trip coil. So here we do not require any station battery, and such type of scheme is used for the protection of the feeders. Okay, and thus circuit breaker operates. Even after there is no any battery, the operation can be done. And this is your voltage transformer part. And again here also what happens here, here your current transformer part is there, and this is the main circuit breaker to which you're supposed to operate, and this is the relay part. And again this is the functioning of the circuit breaker. The trip coil is required, and this is the voltage transformer. You can see it is connected in the star form. And the same thing, you know that already, that voltage transformer will reduce the high voltage to the low voltage. Okay, and the same thing is connected to the voltage coil of the relay. Okay, this is the typical working of any basic relay circuit. Okay, in two ways. One is with station battery and one without any station battery. In both ways your relay will operate. So protective relays are broadly classified into three categories depending upon the technology designed well. So already we have discussed this in a little in your earlier chapter of your module 1. Okay, the first one is electromechanical relays, the second one static relays, and third one is numerical relays. At the first we have electromechanical relays. As the name itself indicates how it performs. How is that? We can see that there is a mechanical over here. So this type of relay operates by applying mechanical forces on moving parts of the power system due to the electromagnetic or electrothermic forces. The whatever force is created is because of electromagnetic or it is because of electrothermic forces which are acted upon the moving parts of the power system. So these mechanical forces will create a physical movement over the moving part, so which will close the contacts of the relays for its operation. So here you can see the desired circuit is operated depending upon the required function. Okay, so here mechanical force is generated due to the flow of electric current. So the name electromechanical relay. So whatever mechanical force is created is because of flow of current. So due to the flow of current only what happens? Your mechanical force is generated. And this generated mechanical force will apply on the moving parts of the power system. And thus desired function is achieved. So again you can see electromechanical relays are used either for electromagnetic attraction type or electromagnetic induction type. Means two principles on which electromechanical relay work on. First one is electromagnetic attraction, second one is electromagnetic induction. So such type of relays are called as electromagnetic relays, which we already discussed in your earlier class. So depending upon the operation and all, there are again two types. The first one is attracted armature relays and the second one is induction relays. Okay, this again we have already discussed. So we know that there are some electromechanical relays which are electrothermic in nature. That is, they follow this principle where forces are created by the expansion of the metal, again due to the flow of again current. So such relays are called as thermal relays. So nowadays whatever relays we get in the market and all, either they will be of induction disc type or induction cup type. So we will concentrate more on these two types mainly, that is attracted armature relays as well as induction type relays. Okay. At the first we have attracted armature relays. So here this relay works on both AC and DC as well. There are around 6 types, namely first one hinged type armature, second one plunger type, third one balanced beam type, fourth one moving coil type, fifth one polarized moving iron type, and sixth one reed type. The other page, the next page. So we shall see each armature relay one by one. At the first again we have hinged armature type. So here the armature gets attracted to an electromagnet due to the application of current or voltage as per the actuating quantity. Okay, so here these relays work on the principle electromagnetic attraction, which you all know. So armature or plunger is always directly proportional to the square of the flux, or it is proportional to the square of the current flowing through the coil. For DC, the force is constant. If this relay is used for AC, then force is variable or pulsating. And here in the opposing force is due to the spring or gravity on moving part. Let us see its working by looking at the hinged armature type relay in the next page. Okay, here we have two figures. The first one is hinged armature type relay, the first one. The second one is modified hinged armature type relay. Let us see why we're going to modify from this to this. So if you're going to modify, means obviously there might be certain disadvantages of it. Yes. So let us first know the principle of working, how it works. Like already I told, it works on the principle of electromagnetic attraction, force of attraction. So you can see this is your electromagnet over which we have wound a coil of a certain length, and again it is either supplied by current or voltage of the system. Okay, whenever, and again this particular part, the one you are seeing at the vertical here, this is called as armature, and it is movable. This is the moving part and this is the fixed part. So whenever I energize the coil with the current or voltage, then what happens? This particular part will get magnetized due to the flux. Yes, so then there is a force of attraction between this electromagnet as well as this armature. So this armature tries to move from this part to this part, that is from right to left, due to the force of attraction. So during this, the force of attraction again increases as it moves because the distance gets reduced. So finally what happens after so and so duration? So this finally gets attracted to it and this attaches to it. As armature gets attached to the electromagnet. So when this armature gets attracted to this, so what happens, you can see before it was a perfect horizontal. Now due to this attraction, so this will get lifted up in the upward manners, this whole part. So whenever this gets lifted up due to the attraction, you can see the trip circuit is open here because there is no any contact between this point and this point. So whenever it's get pushed up, so this and this gets connected, and again the same thing is given to the trip circuit. So trip circuit is shorted, and depending upon the design and all, your circuit breaker will act upon. Okay, so trip circuit anyhow is not given, but other circuit breaker might be there after this circuit, but since we are concentrating only on the armature type relay, only just relay we are concentrating, so we are not showing any circuit breaker over here. Hope you understood this. So I am going to energize this coil by current or voltage depending upon the actuating quantity or operating quantity. So due to this flux, what happens? It gets electromagnetized, and again here force, it exerts force on this armature, since we know the armature is a movable part, and this gets attracted to it, and again due to the attraction this gets pushed up, and this both may get in contact, and again it is given to the trip circuit. Okay, now we know that force is constant for DC and force is variable or pulsating for AC. Yes or not? And here you can see that this particular part, that is half k I square max, is constant part. Again half k I square max cos 2 omega t is pulsating part. This is for the AC component. Okay, since I told right, this type of relay can be used